So a polynomial is made up of terms. Okay? As was mentioned, poly means many, and nomial is kind of saying many terms. Okay? So a polynomial is many terms or multiple terms. Each term of a polynomial uses only one type of algebra tile. Okay? And this includes a positive or negative tile. Okay? So we have 6 different types of terms we could have. We could have ones with positive ones with negative ones with positive x's, ones with negative x's, ones with positive x squareds, and one with negative x squareds. Okay? So we can have 6 different types of terms. Okay? And a term is going to represent a certain kind of grouping where things are all the same. Okay, so a term represents a grouping of a bunch of common things or a bunch of things that are the same. Now, to write a term based on the algebra tiles, we're going to combine the number of tiles, number of like tiles, and the type of tile together. Okay, so we're going to combine the like tiles and the type of tile together. And we're going to start off with a bunch of ones that just have one type of tile in there, and then we'll move into ones that have multiple types of tiles and how that is represented as a polynomial. So let's look at the first one here. Write the term represented by the algebra tiles. We have these algebra tiles right here. And now the algebra tiles I give you will all look exactly the same size in comparison. So if we see something small like this, a small square, that's going to represent a 1. We have 1, 1, 1, 1, 1. Each of those is worth 1. You'll notice that if we put all of them together, we have 5 1s. Okay? So this is going to have the term 5. There are 5 1s, which represents 5. Okay? So 5 little 1s will represent 5. Now, hopefully that makes sense. As you've probably done kind of like base 10 tiles as well in the past, or those 10 tiles. And so these give you exactly that. Now what happens if we have 3 big squares? Well, these are not 1s, these are x squareds. Okay, each one of those is an x squared term. And if we have 3 of them, we're going to write it as 3x squareds. Okay, there's 3 x squared values. Now, if we get to the point of solving, okay, what we would do is we would take a value of x, we'd plug it in here, we'd square it, and then we would multiply it by 3. So this right here is a multiplication statement, 3 times x squared, because there are 3 x squared tiles. Now we don't write the multiplying in there, because if we have a number and a letter side by side, we don't need to write multiplying in there. This here is going to represent one term. Okay, so it represents one term. There's 3x squareds, that's one term. Here's another grouping here. We have 1, 2, 3, 4, 5, 6, 7, 8 of these rectangles. Yep, counted that out right. We have 8 of these rectangles. Now if we think back, each of these rectangles represents an x. Okay, each one represents an x, and there are 8 of them. So we're going to write it out as there are 8 x's. Okay, now this is not 8 times, no, it's 8 x's. X is our variable we're using, and we're multiplying it by 8. So there are 8 x's. Okay. Now we look at this as well. Little difference here. These are all negative x's, so it's negative 8x. Okay. We put the negative in front of the 8 because there are 8 negative x's, and so we have negative. This here is another term. Okay. The negative has to go with it. We have to represent it as a negative. So we're going to put the negative in front, and then how many, and then they are an x shape, so it's a negative 8x. In the same way, this last one here is also negative because it's a dark one. Okay, it's darkly shaded. It is a 1 tile, and so there's only one of them, so it's going to be negative 1. Okay, that's all there is. There's just one of them, so it's a negative 1. That's what's represented by this 1 tile. Okay, and we leave it exactly like that. Now, to do the other ones here, okay, so if we're going to be given numbers and then need to draw out tiles, okay, what we need to do is draw the right size tiles. So let's say a number 6. 6 is positive, and it's also just an individual number. We're going to call it a constant. Later on, we'll go through what a constant means. But we have 6 little squares. There's 6 little squares. Now you'll notice that 6 is a positive, so we're going to leave these open. I'm not going to shade them. I'm going to leave them positive, okay? And the lightly shaded that I have up top there, okay, sorry, this lightly shaded, that represents positive. Or if we leave it empty, that represents positive as well. If we shade them in, it's going to represent negative. Now we do that because many of you are going to use pens or pencils, and you have just one color. So open means positive, shaded means negative. I'm just going to write that down here. Okay, open equals a positive number, and shaded is a negative number. Okay, open is positive, shaded is a negative. If we look at this one here, we're given the x squared terms, and we have 4 of them. Okay, so to draw this out, we're going to need 4x squared. So that's going to be the large box, and we're going to draw out 4 of them. Now, if yours aren't all perfect in size, that's okay. You'll notice mine are not either. This is negative, or these are negative, so we're going to shade in each of these boxes because they all represent a negative x squared. Okay, they are negative x squared. So those are shaded. These are not. So they're positive. These are shaded, so they are negative. The colors don't really matter. I mean, you can use red and yellow. Those are the colors that I used for positive and negative. I'm just going to use shaded and non-shaded. Finally, we have 3 x's. Okay, x is this long rectangle. If you want to do them on the side, you can do that as well. It is a positive 3, so we're going to leave them open. We're not going to shade them in. And this is going to represent 3 positive x's. Now, on that note, I'd like you to work on question number 2. It deals with looking at just individual terms and what each of those terms represents, and we'll get into multiple terms in the next video.